Welcome to AI Frontiers. Today we explore the newest breakthroughs in artificial intelligence research, as featured in the Computer Science Artificial Intelligence section of the arXiv preprint server, dated July 27, 2025. This episode covers 11 influential papers, with a focus on language models, multi-agent systems, safety, and more. Discover how AI is evolving, where it excels, and where it still faces significant challenges. Even the most advanced language models, capable of generating poetry and solving complex equations, can struggle with tasks as simple as navigating a maze. Studies reveal that these systems can loop endlessly, unable to find their way out, highlighting surprising limitations in their intelligence. These failures provide a window into the inner workings of AI, prompting important questions about how these systems think. The research discussed today offers critical insights into these hidden gaps. Today's episode reviews 11 cutting-edge AI papers from the Computer Science Artificial Intelligence category on the arXiv preprint server. We will unpack their breakthroughs, challenges, and methodologies, and examine the implications for science, industry, and society. Our guiding questions: where do artificial intelligences excel, and where do they falter? Join us as we decode the future of AI through the lens of the latest research. To understand the current landscape, imagine artificial intelligence as a vibrant, ever-expanding city. At its core is the cs.AI district, a bustling hub containing research labs, think tanks, and the engines of innovation. Within this district, machines are trained to learn, reason, and even dream, aiming to replicate and surpass human abilities in reasoning, teamwork, and perception. With each new breakthrough, this city of AI grows, reshaping the boundaries of what machines can achieve. The dominant theme in today's research is the performance of large language models, or LLMs. These models power modern chatbots and knowledge engines. Hafstein Einarsson and colleagues in their MazeEval study examined LLMs' spatial reasoning abilities. While these models excel at language-based tasks, they often struggle with seemingly simple mazes, especially when the language of interaction changes. For example, English prompts yield better results than Icelandic ones. The central metaphor: a genius poet, lost in the streets of an unfamiliar city. Another major focus is on multi-agent and reinforcement learning systems. Here, artificial intelligences learn and work together as teams. Joe and colleagues' hierarchical adaptive grouping approach, for example, enables agents to solve real-world problems such as New York City's bike-sharing logistics. Reinforcement learning allows agents to improve through trial and error, similar to cooks coordinating in a busy kitchen. However, coordinating and sharing resources among many agents remains an ongoing challenge. The metaphor: a swarm of robots orchestrating complex city logistics. Hybrid systems and safety alignment represent a crucial area of innovation. These systems combine the structured reliability of classical algorithms with the adaptability of neural networks, as exemplified by H-Frame from Sun and colleagues. Knowledge graphs and retrieval-based augmentation are enhancing AI decision-making. Safety alignment, addressed in Lee and colleagues' blessing and curse of dimensionality work, is essential for high-dimensional models. Dimensionality reduction techniques are being implemented to improve security. The guiding metaphor: Sherlock Holmes meeting a chess grandmaster in pursuit of smarter, safer AI. Key findings from these papers highlight both breakthroughs and persistent challenges. MazeEval demonstrates that large language models, while strong with text, can be weak in spatial tasks. Hierarchical grouping methods, such as those by Joe et al., significantly improve resource allocation efficiency. Lee et al. Expose safety risks emerging from the high-dimensional nature of neural networks. Chan and colleagues' Sci-Tool agent shows how AI can orchestrate complex scientific workflows. Finally, Wang et al.'s policy cliff paper explains the brittle behaviors observed in reinforcement learning, providing a theoretical basis for understanding and mitigating sudden failures. The paper of the day is MazeEval, authored by Hafstein Einarsson and collaborators. This work rigorously tests large language models' spatial reasoning abilities using text-only maze environments. The motivation stems from the reality that many AI agents operate with limited sensory input. MazeEval benchmarks probe whether language models possess language-agnostic intelligence. The test setup is straightforward. Agents receive only coordinates and distance information, with no visual cues. Testing in both English and Icelandic reveals surprising differences in performance. raising important questions about linguistic dependence in AI reasoning. MazeEval's results are both surprising and instructive. OpenAI's O3 model successfully solves large, complex mazes, while other models often become trapped in repetitive loops. Models trained primarily in English display markedly better performance with English prompts. When tested with Icelandic, the same models show dramatic drops in effectiveness. Human researchers liken these failures to chess champions being confounded by tic-tac-toe. The core insight is that large language models' spatial reasoning skills are not universal and may be heavily influenced by their linguistic training. The implications of MazeEval for AI research are significant. The study demonstrates that AI spatial reasoning is constrained by the linguistic scope of its training data. It challenges the prevailing assumption of language model generality and calls for the creation of language-independent evaluation frameworks. The results highlight the urgent need for robust, cross-lingual spatial intelligence and set a research agenda focused on more reliable and flexible AI reasoning. Looking to the future, artificial intelligence is positioned to become a bridge builder across languages, domains, and cultures. Increasing the diversity of training data will enhance the generality and effectiveness of models. The maturation of hybrid systems promises a blend of reliability and creativity, akin to a symphony mixing classical and digital sounds. As interpretability features are introduced, adding windows into the AI city, transparency and trust will grow. This integration will accelerate the adoption of AI in science and industry, supporting smarter and safer decision-making. In conclusion, today's exploration has revealed both the dazzling capabilities and the surprising blind spots of advanced AI systems. MazeEval, in particular, exposes limitations in language models' reasoning outside their linguistic comfort zones. Multi-agent and hybrid systems are already reshaping tasks in the real world, while safety and alignment remain critical priorities, as underscored by recent research from Li et al. And Wang et al. The city of AI is rapidly expanding, and everyone is invited to participate in guiding its future. Explore, question, and contribute to the next wave of breakthroughs. The synthesis and review presented in this episode relied on advanced AI tools such as GPT 4.1 from OpenAI for summarization, DeepGram for text-to-speech, and OpenAI's image generation utilities. All content was reviewed by human experts to ensure clarity and accuracy, though some oversights may remain. Listeners are encouraged to consult the original references for further details. All papers discussed are available for deeper exploration, supporting transparency and ongoing learning. Stay ahead with AI Frontiers. Subscribe now to receive daily insights into the latest AI research. Join our community of curious minds and innovators and be part of the conversation shaping the future of artificial intelligence. Channel AI Frontiers, your window into tomorrow's technology breakthroughs. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.